So the browser interface over here, you can see the RhinoCAM's machining browser and then the machining objects browser. These windows can either be docked side by side, or you can rearrange them, or even have it docked one below the other, so you get more, work area in Rhino in your viewport space. There's two main tabs on the machining browser. You have the Program tab and the Simulate tab, and you work your way through working through each of these groups as you go from left to right. The Program is where you define your machine setup, define your stock, pick your material, set the 0, work 0, start programming your toolpath, and then you go to Simulate to run a verification. The machining objects browser allows you to define different types of cutting tools. You can create your own tools under each tool type, save them to a library, and then reload the library in RhinoCAM as you work with them. So there's different tool types you can create, also for drill, standard drill, reamer, tap bore, reverse bore. You can define tools under each tool type, establish your tool numbers, tool material, feeds and skids either be set. You can manually enter them or use the load from file option. And depending on the type of material you're going to be cutting, the tool material, we have a recommendation like a feeds and skids calculator built into it. And all of this information can be saved to a tool library. So each time you open Rhino, the same libraries, last loaded libraries, automatically loaded for us. There be any questions so far?
Not yet.
Okay. All right. I did notice that you emailed us several different files in here, and yes. I wanted to ask you what would you like to start with, and I see you have a DXF file, you have an STL file, and you have a bunch of other image files like a PNG or a JPEG files in here.
So a lot of my stuff, at least to begin with, is going to be pre-built STL files like that last file. So.
Okay. And what program do you use to create those STL files?
Right now I'm using Aspire. As I told, my biggest headache with Aspire is it doesn't have the advanced toolpaths to save time.
Okay.
It's strictly a raster type toolpath.
Back and forth. Okay, makes sense. Okay. All right. Now, is this part that you created, is it saved in millimeters or inch units? Do you know?
Inches.
Okay. So when we open the file in Rhino, it gives you this file options window, and I can drag it into it, and so it'll open, and it'll open the file, and it can allow you to pick the units in here. So you can say inches or millimeters. I'm going to set it to inches, then select open. So let's go in and display the model in a shaded view. Okay, looks pretty nice. Okay, here, so let's verify the model dimensions in here. So if you go into the RhinoCAM machining browser, you can just select stock and box stock. This will actually give you an overall dimension. So you don't even have to do any measurements in Rhino. If you pick stock and box stock, it basically computes a tight bounding box that will encompass the XYZ extents of the model and gives you the length, width, and the height.
Correct.
These dimensions look correct, approximately for the part that you designed?
Yes.
Okay. All right. So then we don't need to switch the units or scale the model, so we can go through our workflow. So the units in Rhino, you can see at the bottom is set to inch. If you ever need to change it, you can right-click, go to unit settings, and you can always switch the unit to a different one if you need to. So RhinoCAM plugin will continue to work as long as you're working in inches or millimeter units. So the typical workflow in here is, first step is you define your machining process. For 2- and 3-axis machining, you leave this as 3-axis. If you want to do multi-axis, 4- and 5-axis, these are available starting with expert and pro configurations to do 4-axis, index 5-axis. We also go all the way up to simultaneous 5-axis. But today we'll be primarily focusing on the 2- and 3-axis machining here. So you define the machine. The next step is you can select the post processor. You can either do this before, at the beginning, or you can do it at the very end before when you're ready to send the post process output code to the machine. Do you happen to know what's the post processor you'd be using?
Rich Auto.
Rich Auto. Okay, so we do have different Rich Auto controllers in here. So let me go ahead and see.
Just with Laguna or Axiom.
Okay, Okay, we have several different posts in here. I will be able to bring in the rich auto as well. Just need to point to a different folder in here. Let me do that while we are working on this here. Give me just one moment. Now you have multiple different machines, or you have a machine from Laguna?
So right now I have a Axiom machine that's just it's a little hobby machine. It's 1 foot square. Then I've got a even smaller Garble machine.
Okay.
That basically does 3 by 5. It's got a 3 by 5. So
okay. Yeah. So let me go back and select the post. So we have posts for Rich Auto. We also have a post for Laguna. We also have the post for the Axiom Precision. So we have 2 of them here, Elite as well as the CNC, just the standard one. And then if you look in the list here, the posts for Laguna are either listed by name of the machine tool or by the controller, or a combination of 2, like Laguna BNR or Swift or HHC, just the handheld controller. So you can pick the post right here. And you have posts for the Rich Auto as well here. I believe it uses like a DSP controller. So we have these different Rich Auto posts. And we can create new posts, as long as they're in standard G code.
okay.
And you also mentioned about Gerbil. We have one right here in the list, GRBL. We can operate in inches or millimeters.
Okay.
So we can pick a post from the list. Then you specify your file extension. It could be NC, TAP, CNC, whatever the preferred extension is for each machine or controller. You can pick that right there. And then we have the option to edit the post. There's a built-in post generator, which we would use for editing the post processors. We can specify and make changes in here as needed. So if your output is slightly different than what our default stock post is outputting, we can always take this, edit it, and then rename the post. We can also customize it for you.
All right.
Okay. So we got the machine defined post. The next step is to create our workpiece, the stock material. So we go to stock, box stock. And as you notice here, the system automatically computes the minimum stock size based on the length, width, and the height. You can change these information dimensions. For example, you could be starting with a stock that's, 8 by 12 or something larger than that, right?
Right.
You can define the stock size in here. I could say it's going to be 8 by 14, for example. And then give it a height or thickness. Would this be like a 1/2 inch material you're going to be starting with?
Probably 3/4.
3/4. Okay. So I'm going to define it right here, stock. So you can see that the stock is now created. I can toggle the display of the stock. The stock now appears on the viewport. The next step is to align the stock to the part. I could pick align stock. And in this particular step, I'm going to have it centered in X and Y. So you can see there's no factory edge being left on the stock, or I can choose how I wanted to align it. Okay? So once I align the stock, the next step is I want to do a Z alignment of the stock. So if you take a look here, I could do a Z alignment to be either at the center, top, or bottom. So depending on how you wanted the stock to be aligned. So if you pick bottom, the bottom of the stock is flushed with the bottom of the part. So which means we got to remove all the material off from the top right in here, right? So if I pick the Z alignment to the top, then you end up leaving more material at the bottom.
And in this case, it would be aligned to the top.
Aligned to the top. Now, once you align it to the top, if you go to the front view, you can see that there's more material being left at the bottom right there.
Yep.
Okay. Now, if you do want to leave some additional stock on the top just to kind of face it down or something, I'll show you how we can move it around and then change it. So the next step is basically establishing the 0, 0. So we just set world coordinates. You can choose where you want to put the 0, 0, 0 to. Set to stock. You can do higher Z, which is the top face of the workpiece of the stock blank. Or you could, then you can pick a corner, northwest, west, southwest. You can choose where you want the 0, 0 to be. In this case, it's going to move the part and the stock to the origin in Rhino. When you pick OK, it shifts the part and the stock origin. So your machining origin and the CAD origin is coincident. Any questions?
Not yet. So.
Okay. So if I want to move this part slightly below the Z0 plane, I can actually select this entire part And you can use your gumball in Rhino, and you can say you want to move it down maybe like 50 thousandths, right? Just to not have a, material surface top just slightly below that. You can lower it down by 50 thousandths right there.
Okay.
Any questions so far?
No, your system is pretty easy once you just start to learn it.
Yep. As you can see here, I'm just working my way from left to right. Define the machine, post, make sure the orientation is correct, stock, aligning. Then the material selection. I could pick wood, or if you want to have different type of wood, there's this material file you can customize by going into this directory in RhinoCAM. You can just go browse to that folder right here, and then basically you can go ahead and edit the file right in this directory.
Okay.
So you can add additional material types in here. You can expand view this XML file in a notepad or a text editor. You can add material texture, images, as well as materials to it to customize the materials. So the next step is basically this can help you in determining feeds and speeds and also applying a texture when you run a simulation. The texture for simulation, as well as helping you determine feeds and speeds. So now we are ready to machine this part. If you do want to do like a facing cut to take out the material, so you can start like a two axis and facing. I can pick a tool, maybe use a 1/2 inch end mill or a 3/4 end mill. Just go ahead and face it down to the thickness of the part. I can choose to do like a linear cut pattern, run it along the length of the piece because we have more travel on this on the length. Specify any cut levels, generate. So in this particular case, it's going to look at the maximum height of the part, and you can see that it's just 50 thousandths below. It basically automatically puts it to the top face of the part. And you can always go back and make edits to your operation, make changes. You want to change your step over. You could change your cut levels, entry and exit, then just do a generate. Switch to simulate, pick the play button to run a cut material simulation. There's our roughing operation. Then saving this part in Rhino automatically saves it with the machining operations that we programmed.
Right.
The CTM file will include not just the CAD data, but also the machining information that you put on it. So the next step is we want to do some roughing and finishing operations. So we would start with 3-axis. We have different methods in 3 and 2 axis that are offered. In the 2 axis, with our standard configuration, you have all the way from roughing through knife cutting, starting with the standard configuration. The remachining is offered only in the Pro configuration of our product. As far as 3-axis machining goes, the standard includes roughing, parallel finishing, horizontal finishing, radial, and spiral machining. The Pro offers all of the advanced 3D methods like re-roughing, rest machining, advanced 3D finishing techniques. You're not just limited to parallel and horizontal and radial and spiral. You have more types of 3-axis finishing methods. And also the Pro offers you the ability to program from multiple orientations. If you need to machine from the top, flip it over to from the bottom. You don't have to create 2 different files. You can add new setups in here to program it from additional sides or orientation.
Okay.
So the typical workflow would be once you have this faced down, you wanted to go ahead and do a roughing process. You can start with a 3-axis, select horizontal roughing. This is also known as roughing in levels or Z-level roughing. You don't have to go ahead and select any solid or surface geometry. RhinoCAM will automatically look at the entire model that you have imported in here or modeled in here, and then takes into account the stock that you define to create the areas for roughing. So you can specify a tool for it. You could say this part is fairly small. There's a lot of detail and features in here. Maybe I can go with a 1/4 inch flat mill, for example, right? To rough it out. Set feeds and speeds. You can load it from the tool automatically, or you can change the feeds and speeds. Clearance is your safety plane for all your transfer moves, non-cutting motion. You can specify your cutting parameters in here, like the tolerances for roughing. You can specify the cut patterns for core and cavity regions. Step overs can be set. In the cut levels, you can say how fine you want the cutter to step. You can do a % tool diameter, distance, or number of levels. For example, I could say I want to go maybe 10% of the tool diameter only. So if I'm using a 1/4-inch cutter, I'm only stepping down 10%, which is 25 thousandths, right? Or if I want to step down 50 thousandths, I can say 0.2 or 25% of the tool diameter. I can use these controls in here. In cut levels, I can say I don't want to go below a certain Z level. So I can say I want to pick my bottom containment, and that's how far down I want it to go. I don't want to go past that, right? That's the lowest point of the model. I don't want to go past it. I can put a bottom containment in here. Then set my engage and retract parameters, how you want to engage in material when you're ramping in, and how do you want to do it when you're extending on the side. And you can also fit arcs to your tool paths. Rather than outputting them as linear motions, we can output them as true arcs. So when you pick generate, it's going to compute the roughing tool path. So in this process, it's looking at your part, stock, and computing it. So we are not selecting or specifying any boundaries. We could still contain the tool paths by specifying machining regions and boundaries, which we'll talk about in just a moment. So here's your roughing path, and it takes into account the entire stock that we had, and you can see it's doing it in levels, and you can look at each of those levels. And those dark blue motions you see on the tool paths are arcs being fitted to it, and the turquoise color or the cyan color are all linear motions. So if I go into the simulate, click play, it shows you a material removal simulation. You can always speed it up right here. So it's doing it in levels, each level at a time. I could always do a pause, pick go to end, simulate to end. It gives you the roughing in levels. Now, since I already had roughed down the top by a certain amount, I can skip that for the face. Since we did a facing operation to face it down, I can go back into the roughing operation and tell it that I don't want to start at 0. I want to start maybe at minus 0.06, right?
Okay.
Or 70,000, 60 or 70,000. I can start right there. I can change it to 75,000. So that my first cut will not be until 75,000 because we removed that amount of material. And we can also apply colors for simulation. So it makes it easier for us to see how the material is being cleared out. So you can go to properties, and you can apply a color for each simulation. I could say for the roughing, I would like to apply this color. So now when I go to Simulate tab, the facing is completed, and I'm going to apply based on the operation. I'll select the play button, and now you can see that the material being removed with the roughing operation can be clearly visible. I'm just doing a pause, simulate to end. Any questions so far?
Not yet.
Okay. So now for finishing, we have different ways how we can finish it. Now also for the roughing, if you didn't want to cut all the way around, we can pick a boundary in here to contain or limit the tool paths. So we could go in and select a region. One of the ways we could do it in Rhino is using in the layers, I can insert a new layer so the boundary can go on a different layer. And Rhino has a command called mesh outline. I can just pick this mesh right here, right click or press enter. You can see it creates a nice little outline on the model right there.
Okay.
So now I can take this outline. I can offset this outline boundary a little bit by a small distance. Maybe I could say I want to go maybe by a 1/4 inch offset, or maybe 0.200,000, and then offset it. So this is going to basically take the curve and offset it. Now, if Rhino is unable to offset it to a closed curve, it could be possible there's some self-intersections in here. You can say that it's offset into open curves. So Rhino was not able to offset that very effectively. So what we could do is take this curve, we can make a copy of that, and then we can rebuild one of these curves in Rhino to smoothen it out. You can see there is about 2,600 points. The curve is made up of so many point count. So I can simplify it to like just 250 points right there. And then I can offset this. I should be able to offset it nicely. See that, sir?
Okay.
So the offset is used for defining like a boundary for containment. So in the roughing operation, rather than roughing it over to the entire part, I could pick this as my boundary to contain the pad and generate it. So the tool path is going to be contained to that area only. You see that?
Yep.
So if you wanted to add a facing operation, so I can make a copy of this facing operation in here, and I could select the facing operation to have the extent of the stock that we had defined, which was 8 by 14, so which could be a rectangle that we can define 8 by 14. Now I can create a second facing operation to quickly clear this material out by just picking these two boundaries in here. And then I can select a tool for it, the 3/4 inch tool, and then in the roughing, I can specify to do like an offset cut pattern. And I can choose to go from the top, which is going to be 0, down to the depth, maybe like go down to like 1/2 inch deep, right? And then generate that. So in one operation, I can basically, make my machining workflow much more efficient. And then this could be our next operation to rough it out in here.
Okay.
Do you see the benefit of how you can have more precise control on your toolpath?
Yep.
Okay, so we got the spacing done. Now the next thing we want to do is we want to do some finishing operations with it as well. So we have different types of finishing methods available. So starting with like a parallel finishing. This would be also similar to what some systems call it like a planar finishing, or basically follows the 3D geometry, and it can cut in different direction of cut, angle of cut. So either cutting it parallel to the X or Y or any angle like 45 and stuff like that. So you can pick a tool for it. So typically you would want to go with like a ball mill. So if I choose like an 1/8 inch ball mill for this, or you can even go with like a taper tool. Again, specify the cutting parameters. You can change the angle of cut in here. So if I put it at 45, it's going to go at a 45 degree to X. So rather than just going back and forth, it'll go at a 45 degree angle. You can control your step over, how fine you want it to step. You can put in a Z containment, so you don't want to cut past that. Or I can say go down to 1/2 inch. And you can also control your step overs, specify your clearance. I can skim through, then generate it. So in this process, this could be like a pre-finishing operation or even a finishing operation. You can generate the toolpaths in multiple cutting directions. So we have our parallel finishing operation in here. So if you select play, and I didn't change the color for the simulation, but you can see it's cutting back and forth following your 3D model. So that's going at an angle of 45. If you take a look at it, looking at it from the top view, it's at a 45 degree cut.
Right.
And then you can always go back and change the angle. So any scalloping that's being left by cutting in one direction, you can always change the direction to cut it from the other orientation.
Yep.
So by picking this curve we just offset, it just gives it enough room for the curve to get all the way down on the sides. And all I picked was this particular curve boundary. I didn't have to select the entire STL file or the mesh geometry. So you can just pick a boundary to contain your toolpath.
Okay.
And if you didn't want the cutter to go into this circular region in here, we could have eliminated that by selecting a inner region in here, so the cutter would stay between the two. So it would know the topology of the geometry what you selected, so it would stay between the two areas only.
Okay.
And anytime you want to skip, we can do a pause and select simulated to end. You'll notice that it's going to run through the simulation. And as you can see, it's running through it right now here. Any questions while it's being simulated right now?
Not really.
Now, what type of toolpaths have you been generating with your current program?
It's only pretty much a raster file. So it's a Z level for roughing, and then I'll normally generate because I'm doing wood most of the time, I'll normally choose an angle across the grain of the wood, so I'm always cutting cross grain.
Okay.
Like I've got
it's running through the simulation right in here. I've chosen to go to N because there's so many toolpath motions in here. I can speed things up. I've set my simulation accuracy to run it really fine, so you can see all the details that show up as you're simulating it. So if I set the simulation accuracy to standard or pick one of the other simulation models, it's going to go much faster in here on the simulation. And anytime, like I said, they do a pause and then pick simulate to N, it's running through the toolpath simulation, cut material simulation. So let's take a look at some of the other toolpath methods in here as well. I'm just going to wait for this to finish. We'll give it a minute. While it's working on it, do you have any other questions or anything in particular you would like me to cover during this demo today with you?
The next biggest thing is I just got to get more familiar with Rhino and drawing in it.
Okay, so have you been using Rhino already, or are you trying to get familiar with Rhino?
I'll need to get more familiar with Rhino. I mean, I've been using primarily Aspire because especially when I'm doing the artwork to get the contours and that, it's just a lot easier for me to. The way it's set up and designed is a little bit easier for me to understand than using RhinoART. So part of what I'll have to do if I do go with Rhino is I'll have to get the training packages for Rhino proper and with RhinoART, so that way I can better design work. I mean, this model here I bought, and then I added the text, and that very middle section where it's got the 578 and what looks like waves, that was all added with Aspire to the model itself.
Okay. So, for example, if I wanted to do like a circular cut pattern or radial cut pattern in here, we can define a boundary. So I'm going to go ahead and use like the drawing tool in here, and I can draw a circle with the center. I can approximately kind of eyeball the center right here, and then put a circular boundary right there. You see that, sir, right here? So I can choose that, and then I can also, adjust it a little bit in here. So now with this circle selected, I can program this using different types of finishing methods. So in the standard and expert, you have radial and spiral machining. So I can do radial machining. I can pick this region, use the same tool, or if you want to use a larger tool. In the cutting parameters, you can specify the step overs, and then you can choose whether you want to climb or conventional cut, start from the inside or start from the outside, and then generate. So this would give us a 3-axis radial finishing toolpath. So we are not just limited to parallel finishing only or raster machining only. You have more options in finishing. So this one gives you like a radial machining cut pattern. And also, if you don't want it to go all the way down to the center, you can leave a minimum radius in there. You can edit the operation. And then specify to leave a minimum radius on the radial machining.
Okay.
So go to cut parameters. I could say leave a minimum radius of maybe 150 thousandths. So it's going to leave a radius of 150 thousandths off the center. So with the radial machining, so I'm going to move this above in the list here and run this simulation. This cutter path basically.
Let's make that a 16th inch ball.
Yeah, I can pick a 16th inch ball. This one I just picked was a 1/4 inch just to run the simulation, go through it faster in the demo.
Yeah, true.
You can pick a smaller tool as well. So that's a radial machining toolpath. What you're seeing right there. So there's different ways how you can program it. So the circle, what I drew was just to use as a containment. We could
Right.
also do spiral machining. We also have horizontal or Z-level finishing or constant Z-level finishing as well.
Okay.
And if I had specified it to leave a little bit less less radius in here in the center, minimum radius to leave, I can make this just 50 thousandths. And just all I do is regenerate the toolpath. And I can do a simulate to end. That's going to run through the simulation. It goes from start to finish. So that's one of the ways how you can finish it when you have circular features or patterns, which is all available right from our standard configuration. It's called radial machining. There's also what's called spiral machining. With the Pro, we have more advanced 3D methods, like we could do constant 3D step pocketing, which is a uniform 3D step over, and we can specify to it basically uses the curve region that you select to create uniform 3D offset. The toolpath pattern will be the region that you pick, and it's basically creating a constant 3D offset in here. So when I pick generate, this will produce a constant 3D step pocketing toolpath. We also have methods called pencil tracing, remachining to identify bitangencies and scallop and do some cleanup operations with it.
Right.
Now, while this is being generated, I can also generate what is called a horizontal finishing. So you can see this is a constant 3D step over pocketing toolpath. So it creates a uniform 3D step over. Now, to do constant Z-level finishing, we call it horizontal finishing. Again, I can select a boundary to contain the toolpath, or I can just have it generated based on the entire 3D model. I can set a step down. I can do like a 15% step down, and then pick generate. So this will generate a Z-level finishing or constant Z-level finishing toolpath. So rather than just doing rastering back and forth, it's going to go around in constant levels. Some systems also call this waterline finishing or Z-level finishing. So it maintains a constant Z for each cut level and then steps it down in level.
Okay.
So when you have steep sections on the part, this would be a good way to program it.
Like this one has.
Like these sections.
Got the steep sides.
Yep, for the steep sides, this will work very well. So it's working through trying to compute the toolpath, since there are several features on this model. And then once you have all of these operations programmed, you could always take a look at the time for machining it. So if you just select the operations, right-click and go to information, we'll tell you how long it's going to take to cut based on the parameters that you put in for each operation.
Okay.
You can also generate like a shop documentation. I'm going to show that to you, which is like a setup information sheet, which gives you, like a report, which includes a screen capture of the part, the operations that you programmed, the tools that are being used, and so that if you have somebody who is running the machine for you, and you want them to be well prepared to know what to expect out of this code, and you'll be able to generate that report. So this is horizontal finishing here. As you can see, it's following the contours called Z-level finishing.
Okay.
You see that it's going down in levels. If I use the toolpath display in levels, you'll see each of those levels in the toolpath as it's cutting it. So that's Z-level finishing. It automatically identifies the contour based on the cutter that you specify.
Okay.
So that's a horizontal finishing. So I can go in here and run this simulation. So you can do the parallel finishing. You can do a combination of different operations in here and how you want to machine it. So I can go back and change the step over on this one here. I'll just pick the 1/4-inch ball mill. I'll leave it at 20% step over. This could be like a pre-finishing operation that you could do, and then you can go from a pre-finishing to a finishing operation. You can always reorder the operations in the sequence you'd like to run it. So there's the pre-finishing pass with the 1/4-inch ball mill with a much slacker step over. And I can do a pause and pick simulate to end. And it's going to run through the simulation. And you could always change the angle of cut if you want to do a parallel finishing from a different direction. You just change the angle of cut.
All right. Let's take a look at the art section now, please.
Sorry, can you please repeat that, sir?
Let's go and take a look at the RhinoART section.
Sure, we'll do. Okay, so let's go back and before I do that, let's look at the posted code in here. So once you want to output it, so right-click and post. And you can pick where you want to save the file, pick the post processor, and then you click post. So this will generate your G-code output file. It'll automatically display in like a notepad, or if you had it set to a different text editor of your choice, it'll automatically pull up in the text editor.
All right.
Since there are several toolpaths in here, it is working on displaying the output. Okay, so there's your posted code, calls out the tool numbers, and then it'll output the next tool number. If I do a search, you should see the next tool number being output right here for the roughing, for the finishing. Now let's take a look at the shop documentation real quick here. I'll put it as output as a template, like an HTML template. And in this process, it's going to take screen captures of the viewport, whatever you are visible in the viewport. It's going to take a screen capture of that and display it in your shop document.
All right, so that way it gives you kind of a visual what it should be doing.
Mm-hmm. Absolutely, and you can choose how do you want to open this. I'll just use Firefox. Okay, so you can see there's the units, dimensions of your stock, the material, and then the 4 tools that were used. It shows if you had any comments specified, it'll output those comments as well. If I had the stock displayed as a cut material simulation, you'd have, taken a screen capture of that as well.
Okay.
Okay, so now let's go ahead and hit save to save the file. And you said you wanted to take a look at the art module, RhinoCAM art?
Correct.
Okay. And was it on this particular file, or was it on one of the other files that you want me to?
Let's do one of the other files.
Okay, so let me just do a new to save. I've already saved this work. Okay, so we'll go from RhinoCAM on the menu. From the mill, just pick art to switch to the art browser. So there's 2 main tabs. You have relief operations and then raster to vector. Now, let me go into the file explorer here. Okay, I see you got different files in here, like images, right?
Yep.
Let me double click on it to see what they are. Okay, so we got this one here. This right here. Okay, so there's 3 images, right?
Correct.
Okay. So are we looking to take one of this and convert it into like a raster to vector, or what is it that you'd like to accomplish with this?
If we use the I just busted my knee. So yeah, raster to vector, and then trying to figure out just so this one is already. This is a just for this trip I had to see how to take a grayscale and set it up for machining.
Okay.
This file.
Okay. So we'll have to convert this to either a JPEG or a GIF or a bitmap. So what I'm going to do here is JPEG, we can read it. We can read, we'll just go back in here and just rename the extension here. Hopefully that should do it. We'll rename it to JPEG here. Okay. All right, so let's go into the art module. Now in Rhino, there's a way you can also put a picture in as a bitmap, as a background as well. But let's focus on how we can do it in the art. So we first define in the relief tab, we define the extents of the project. So we can pick origin and extents, and we can specify a size for it. So I'm going to start at the origin, and I can specify my extents for the project. So it can be like a 4x4, for example, right? And then I specify the resolution for it, and then I'll pick generate. So this basically creates like a work area, or you could call it a canvas where you put your work on top of it.
Right.
So I could even define a rectangle. I could have snapped to that as well for my work area. So the next step is basically I would go in and choose to create a 3D relief, and then I'll go in to locate that image file. So we have these right here. I'm going to select this and then pick open. And this basically is converting to a 3D relief. That's your original image, and then it's in grayscale, it's in black and white, and you can adjust the threshold. So the lighter the colors you have, the more height you're going to get on a relief. The darker it gets, it's going to reduce the height. That's a typical how the relief conversion works. And you can choose whether you want to add to this. We want to add it to the existing sheet that we've defined. And then we can specify to use either the image size, or we can specify a size in here. I can pick a size, and I can just go snap to, let's say, this is the area I would like to put it into. I'm just keeping it shy of a quarter inch from the edge. I can specify the maximum height for the relief, and I add any smoothing factor in here. And then I pick generate. So in this process, it does what is called a 3D relief. If you look at the entire project and go to the shaded view here, it creates a 3D relief. So the lighter the colors, the more height you're going to get. The darker it gets, it's going to reduce the height.
Okay.
Now this is what we did. We just said add, so it's adding to the base sheet. The base sheet has no thickness to it. So once you have this created, you can select the project, hit export as CAD, export meshes to CAD, so it becomes a Rhino mesh, which is basically like an STL file in Rhino.
Okay.
So now that's been exported, which is now ready for programming. So we can switch from the mill, art the mill module. We can define our stock in here. I can give it a stock thickness. I could have saved the operations I programmed on the file into a knowledge base. Using save to knowledge base, I can load the operations, or I could just program it in here. Do a 3-axis roughing path. If I wanted to contain it, I can select a region. I can specify my cutting parameters, and then generate.
Okay.
So it's creating a roughing path, and then you can go ahead and add a finishing path to it, like a parallel finishing. I could specify the tool, specify the cutting parameters, generate. And then we can run a simulation. So there's our roughing operation and the finishing. So just to give you a quick workflow of how we can use the art. There's several different ways operations you can do in art, like you can do puffed volumes, swept volumes by selecting curves. And then if you want to go back and clean up these bitangencies in here, we have what's called pencil tracing. That's available in our Pro configuration. It automatically identifies these bitangencies on the part and creates a path to go clean it up. As you can see here, it creates a toolpath based on the bitangencies of the model to go back and clean it out. So it'll eliminate all of these scalloping that you're seeing right here.
Right.
So that's called pencil tracing.
Okay.
So that's one of the options available in the art module, is basically doing a relief operation. You could do a add, subtract, intersection. You can also take curves. For example, if you wanted to do raster to vector, you can use curve from images. I can pick this object in here. I can convert it to black and white, or I can invert the colors.
Okay.
You can also adjust the threshold in here. You can see based on the threshold what you said, what are the features it's going to extract, right?
All right.
So this is basically mapping it to the closest pixel based on the resolution that you put in. And then I can go to vector edits. I can specify a size for it. Again, I can snap to like these 2 points right here. And then I can set a resolution and then pick generate. So in this process, it's going to create those curves. Let me hide this in here so it makes it better, easier to see it. So that was a raster to vector I did operation by using those curves, right? So based on the, what's visible in here, it creates them, and you can also adjust the smoothness. So if you don't want to smooth it out, you can pick generate. You can see it's going to be looking much coarser. It's basically mapping it to the closest cell in the, resolution that you put in. Its resolution is more like a grid. So if I change this to 250 and generate it, it's going to probably give you a much better result. And then I can always do smoothing it out by doing a arc fitting in here, smoothing it out, and then you can also add arc fitting to it. Now, once these are created, you can always export them as curves to RhinoCAD. So now these are curved, and you can take these and edit it in Rhino. You can also rebuild them. So that's the advantage of working within Rhino, is you can recreate some of these or modify them as you need to.
Okay.